Okay, well, hello there, boys and girls. We are starting. I'm going to start over. We are beginning a whole new series on mathematics, looking at it from the foundations and building up. 1.1 here has to do with patterns. Now, in mathematics, patterns are essentially the most important thing we study, really. I mean, they have defined mathematics as being the language of patterns, how we describe patterns we find in nature, science, within pure numbers themselves. So it's a really important thing to study. In fact, it's so important, I would argue that maybe it's the most important skill you get in a mathematics education. The ability to break a problem down and observe the underlying structure or pattern and then make an extrapolation, make an advancement, make a prediction based on the pattern you find. Okay, so here we're going to start with a problem, really simple problem. Suppose you have 26 students in a classroom and it's elementary class on Valentine's Day, like they often do. They exchange valentines. So each of the 26 children in the class are going to exchange valentines with every other person in the class. And the question is, how many total valentines will be exchanged? Okay, well, think about it for a minute. You can pause me and I'll wait. Okay, now you're back and hopefully you've come up with an estimate or an actual solution. And I'm going to show you that really, if you're having a hard time wrapping your head around the actual final solution, you might take a look at just a smaller snapshot and build that pattern as we go. For instance, suppose there are only 0 students in the class. Well, that would be easy. If there are no students in your class, you would have 0 valentines to exchange. If you had 1 student, very lonely, single student, maybe homeschooled, they would have no one to exchange valentines with. That's a bit sad. If you have 2 students, though, now you have valentines to exchange with each other, and that's 2. Well, okay, so that's maybe that's what you're thinking the answer is. It's going to be always the number that you've got of students. But if we have 3 students, how many valentines will be exchanged there? Well, we can represent that maybe with 3 dots. And you could say, well, this person is going to give that person a valentine and that person a valentine. And this person up here will give that person a valentine and that person a valentine. And then that third person will reciprocate and give valentines back to each of the other 2. And if you count up your arrows as valentines, you'll see that there are in fact 6 valentines that you're going to be passing around that room. If we go to 4, same thing. You've got 4 dots and person number 1 gives out 3. Person number 2 gives out 3, like this, and you'll see that then person number 3 does the same thing, and if you count up all of your arrows, you're going to get 12. Okay? Well, you don't have to do this too much longer till you start to see a pattern that however many dots you have, each one of those dots is going to give a valentine to every other person in the class, but they don't give one to themselves. So if we have 26 students in the class, 26 students will be giving out 25 valentines each, and then it's just a simple multiplication problem. 26 times 25. And if we go back, we can see that, well, yes, this is 2 times 1, and this is 3 times 2, and this is 4 times 3. This then, of course, is 1 times 0. And it makes sense. All right? So the multiplication for 6 times 25, what is the actual final answer? It's easy to multiply by 25 if you think about 25 cents in a quarter. If we had 26 quarters, we'd divide that by 4 and we'd get $6 with 2 quarters left over, $6.50. 650 valentines exchanged in that classroom. Okay? So in this section, we're going to be doing this technique where we're giving you a problem. It's quite a large problem that many people or many slices of a pizza or whatever it might be. And you're going to break the problem down and look at it from the very beginning and try to think of the first few steps and then come up with a pattern and using some of our mathematical tools describe that pattern and then make a prediction or solve the problem for a much larger number. Very simple, but can be pretty difficult. But it can also be incredibly powerful and useful technique. Good luck.